Hello dear students, as you know that we are studying about Laplace transform, in which we have seen the Laplace transform of 1 and which is 1s, and Laplace transform of t raised to n, then t raised to n gives us gamma of n plus 1 upon s raised to n plus 1. Now we will see some more basic results in which if the Laplace transform, first of all the definition of Laplace transform of f of t is equals to integration 0 to infinity e raised to minus st f of t dt. It is the definition of Laplace transform, and we are going to find the Laplace transform of f of t, where f of t is equals to e raised to t. Correct? So Laplace transform of f of t, replace f of t by e raised to at, we will get integration from 0 to infinity e raised to minus st e raised to at dt. Correct? And we have t in common, so we can write it as integration from 0 to infinity e raised to minus s minus a t dt. Correct? We have taken minus outside, s minus a t. Now integrate this, we will get e raised to minus s a t upon differentiation that minus s minus a. Correct? And limit running from 0 to infinity. Since it is filled from t, so we can take outside minus 1 upon s minus a and 1 upon e raised to s minus a t 0 to infinity. Correct? Now minus 1 upon s minus a as it is, then if we go to infinity, it becomes infinity 1 upon e raised to infinity, and when we put 0, then it becomes 0 e raised to 0. So we will get minus 1 upon s minus a e raised to 1 upon e raised to infinity means 1 upon infinity, and 1 upon e raised to 0, since we know that a raised to 0 is equals to 1, so e raised to 0 becomes 1. We have minus 1 upon s minus a, 1 upon infinity becomes 0 minus 1 upon 1 1, and after multiplying we will get 0 minus minus becomes plus 1 upon s minus a, and it is the Laplace transform of e raised to a t equals to 1 upon s minus a. It is the Laplace transform of s minus a. Similarly, remembering this, Laplace transform of 1 upon Laplace transform of e raised to at is equals to 1 upon s minus a. So by using this, we can find the Laplace transform of trigonometric function also. So see how to find the Laplace transform of trigonometric function such as sine at and cos at. So let's see. Let's see the sine 80. F of t is equals to sine 80. And since we know that sine 80 will give us e raised to iat plus e raised to minus iat upon 2i. It is the Laplace, it is the sine 80 is equals to e raised to 80, e raised to iat minus e raised to minus iat upon 2i. It is the exponential form of sine 80 Now, if we want to find the Laplace transform of this, so we can write it as sin at is equals to integration from 0 to infinity e raised to minus st sin at dt, correct? And if we replace this sin at by this, we will get integration from 0 to infinity e raised to minus st e raised to iat minus e raised to minus iat upon 2i. Since 2i is constant, we can take it outside of the integral. We will get 2i outside, and we can separate this integral integration from 0 to infinity e raised to minus st into e raised to iat dt minus, as it is, integration from 0 to infinity e raised to minus st e raised to minus iat dt. Correct? And we can solve this by very easy method, that taking e raised to minus outside s iat dt minus integration from 0 to infinity, taking again minus sign outside s plus iat dt. Correct? After taking integration, we will get e raised to minus s minus iat upon minus s minus I minus e raised to minus is iat minus s plus ia and 0 to infinity. Whenever we put infinity, we will get a 0, and whenever we put 0, then we will get 1. So from this putting value, we will get 1 upon, or let's take minus 1 upon s minus I outside, then 1 upon e raised to s iat, and limits are 0 to infinity, minus, again taking minus outside, become plus 1 upon s plus ia, and we will get 1 upon e raised to s plus iat 0 to infinity. And whenever we put infinity, it becomes 0, and whenever we put 1, we will get minus 1. So we will get 2i 1 upon s minus a, and we will get minus 1 upon s plus ia. And after simplifying, you will get 1 upon 2i s plus ia minus s plus ia, and it becomes I square, s square, I square, a square. So minus s plus s will cancel. We will get 1 upon 2ia upon s square. I square becomes minus 1 and minus become plus a square. 2 get cancelled, I get cancelled. We get a upon s square plus a square. This implies that Laplace transform of sin at is equals to a upon s square plus a square. And it is the required result for trigonometric functions sin at. Similarly, we can find cos at, but we have just e raised to iat plus e raised to minus iat upon 2. Without I, we will get cos at, and similarly following these all steps, we will get again Laplace transform of cos at as something s upon s square plus a square. In next lecture, we will try to see that Laplace transform of cos at also. In this lecture, we have found two Laplace transform of, first example is e raised to at, which is given as 1 upon s minus a, and another is Laplace transform of sin at, which is a upon s square plus a square, and it is quite important basic results of Laplace transform. You have to remember all the basic results: Laplace transform of 1, Laplace transform of t raised to n, e raised to at, sin at, cos at, and all are. You have to remember. In next lecture, we will try to get Laplace transform of cos at also. Till then, keep watching our videos and stay tuned with us. Thank you.